I'm not saying when a Spark is there. So I'll be talking about this Spark uh, in every section whenever we talk about processing part. So MapReduce was built before Spark, and both are designed from same lab, UC Berkeley. Okay, so this built in AmpLab and this also built in UC Berkeley, University of California only. But when developer designed this MapReduce, they internally thought that we have given a big limitation to this MapReduce, that this MapReduce can only process historical data. This is specifically built to process historical information, okay, not a real time data or not a near real time data. Then how about the Spark? The Spark is now is 2.4.5. Okay, and guys, if you're actually looking for certification such as Cloudera certification and other thing, right? So all questions are coming nowadays from Spark. But I'm not saying that you should not read MapReduce. We have two agenda, right? After doing this course, first one, people will try for interviews, right? Joining some company as a part as a designation of data engineer. But uh, MapReduce you will come in interview questions. This is a core fundamental of Hadoop. Okay, I'm not writing that is a different case, but conceptually we need to be very clear in MapReduce, because this idea of a Spark is inherited. It came from MapReduce only. That what we are doing in MapReduce, the same can be achievable using a Spark. But since this is a later technology, they have taken some of the very beautiful concept of MapReduce, uh, traditional terms, and they use a caching concept so that they can increase the performance of processing. Okay, so how Spark is built? This is having an idea of processing historical data as well as real time data. I'll visit this part later. This is last of the course, like when we discuss about a Scala and a Spark. Okay, but one quick point to collect here is MapReduce is only eligible to handle historical data. Spark can handle historical as well as real time. Okay, so both can be handled using a Spark. MapReduce, this is a traditional method. So MapReduce can distribute the data and can read the data from HDFS and process them. Spark also does the same thing, but Spark is not having any dependency over HDFS. I can definitely read my input from HDFS, or I can use Amazon Web Services and use a S3 bucket also. So my input location is multiple here in Spark, but here in MapReduce, my input location is one. I can read it only from HDFS. Okay, so there's a couple of points which where we can say that Spark is standing much robust than this MapReduce, or logic or APIs which I'm using in Spark. It's fairly simple compared to MapReduce. It's like I'm writing 100 lines of code in MapReduce, just at 10 lines, and double down, like your job is done. So this is what is a quick difference between MR and Spark. That uh, historical, they can handle both. This we got in 2008. So first stable release of MR we got in 2008 year, uh, 12, 12 years ago almost. And Spark stable version we got in 2012. I think this is 2012 to 2014. So due to this Spark thing only, Scala journey, Scala thing is getting hotter, because Spark is inbuilt. Spark API is designed using which language? So this is having an idea of Java. So MR is built on idea of Java. They uses core Java and native C. Sometimes they have built the few concepts they have built in C also. So they are inspired by Java and C, language wise if I say, but and Spark is inspired by Scala. So native language, why it is important to understand native language? Okay, because when I write a code in a Scala using a Spark, native language are compatible. native language are very much compatible with other languages, right? So this is a native language, I'll say. Let me write in a bracket that these are the native language for MapReduce, and this is a native language for. So we're not going to learn any traditional technology. Don't worry, I'm not going to start Java something. I'll talk about latest technology, which is Scala, and you'll find this is very easy. You just need to remember, since programming language are built with the concept of multiple principles, right? So we need to know rule, we need to know sometime discuss about the syntax also. Now syntactically all is different. If you ask me how I'm writing in Java, how am I writing in C, in Scala, and Python, syntax is all different. But suppose if I'm giving you a task and I ask you to write a code to transform this data, right? And I'm not giving you that you should write in a Scala or Java. I'm giving you that option. I'm leaving that choice with you. I'm saying you can pick up any language and give me output. I'm just looking for output. Your code, your logic can be written in any language. Okay. So when we write a pseudo code, when we write a simple rule like if else condition, or when I create a flow, or when I'm using function, I hardly care what logic, what syntax you're using, because nobody's perfect here, guys. Syntax, I make often mistake here in syntax. So what we do, we simply go to Google, we see the syntax and we use it. But what is more important, this syntax will come later, but what logic is you're writing, that's important first. And this logic can be written in any of the languages. The beauty of this uh, whole Hadoop big data and other ecosystem, they support multiple languages. So MR is having Java. See, they have a support for Scala and Scalding also. But Spark, you'll amazed to see this number. The Spark supports many languages. Let me write this down. So Spark supports native is Scala, but it has a support for inclusive of Scala. It supports Java, it supports R, it supports Python, SQL. Okay, so 5 languages inclusive of this. Now first thing, why they are supporting multiple languages. So say I'm working in Python. I'm a Python programmer since last a decade. Okay, for several decades. So let's say I'm working since last 12 years with Python. Let's just say 12 years with Python, and suddenly somebody says me that I want to learn a Spark because this is a new technology and I want to upgrade myself, but they're saying me that you need to learn a Scala first before learning a Spark. So I may not be comfortable to moving to this technology. Now how I can increase the efficiency and demand of this technology to providing multiple platform, so that anybody is coming from any programming language, they can quickly understand only Spark and they can write their own language, their own logic with any of this programming. So whenever you see this API is supporting multiple programming languages, which means they are developed by community. They supports multiple syntax, and anybody can work with Spark. There is no foundation, because when this came earlier, right, when MapReduce came in 2010, got popular in India 2011, we started working personally. So it was a first question for everybody, that the same question I even had for myself also, that if I don't know Java much and I'm not so much comfortable in Java, then can I work with a Hadoop? Can I work with a MapReduce? So answer was yes, because they provide me all the APIs, all the programming languages which I can use, which I can write, and with the help of MapReduce and get my answer. Okay, so these are all different points to discuss with MR and Spark. Now, if I give you benchmark, right? If I give you benchmark that how much time MapReduce can take to process one data, and what is the time efficiency of Spark. Now MR in 2008, we observed this in 2008, the same year where when we get MapReduce, and this was I get done in 2015 or 16. I'm not so sure with this number. So year, this can be anything, 15, 16. Never mind. 2008, we process 1 terabyte of data. Okay, and here in 2015 we process 4.27 terabyte of data using How much time? So time here was 60 second, and the best part is same time here also. So if you just see this 3 point, year, data, and total time. So my data volume is very high. I think almost 5 times here, and time is almost similar. And one more factor to uh, to remember here, that how many machine they are taking. Because when we talk about Hadoop, we are saying cluster, right? And we know cluster is group of machine, multiple instances we connect with the same network, and we call that as a cluster. So this is using the cluster of 910 nodes, which means I have a single cluster where I'm having this many machine available. Big number, right? This cannot be cost optimized if I'm not using commodity hardware. So often we say Hadoop uses commodity hardware. Okay, let me write a point. We mentioned that Hadoop uses commodity hardware. So first, see different types of hardware. Okay, so types of hardware we have: one is a commodity hardware, and second is a enterprise hardware. So I'm taking you towards infra. Okay, this is the infra side. Hadoop uses commodity hardware. What do you understand by commodity? This is a terminology. Commodity means, in plain English, we can call it's a cheaper. It's a cheaper hardware. Okay, so when I work with a large data set, and I want to perform commissioning and decommissioning very frequently. Commissioning means adding new nodes, and decommissioning means removing the existing node if we have any failure, any data issues, any network issues on that node. So cheaper is commodity. Enterprise means costly. Like if I give you one difference between HDD and SSD, right? So HDD can be a commodity, a simple hardware. SSD is an enterprise hardware. It's a solid state drive. They are magnetic types, which Amazon uses. So you guys have created your account, you guys have created your instances and set up your Hadoop. So you uses SSD. That's the enterprise, which means fairly faster than commodity, but obviously they're costly. So here in Hadoop, we are using this commodity hardware to store and to work with instances. Now, you know how many node we have used here in this Spark cluster? It was just 209 nodes, almost 4.5 times. I think 4.5 times less than this, almost. So obviously, if I give you a choice that you whether you want to work with a MR or Spark, and one more thing, that lines of code. So here you're writing 100 lines of code, and here you're writing a 10 lines of code, right? So uh, we will see this point also, that I'm writing more code, more lines, so my size will be very high here. My size is very less here in a Spark, and hence I can decrease my size. I can create one lightweight application and deploy that, which will take less time. So whenever your size is less, your time is also taking less, and size of your application is also less. But why this is much faster? Why this is much faster compared to MR? We know all this point we can compare, but why? What logic, what algorithm they are using internally, so that we can say they can also get me answer, but it can take time. They can be just quick. One single line difference, that concept of MR is using concept of disk computation. Very important point, guys, because this question can come, and we know what logic, what method we are using, but sometimes we forget that what computation is built, what computation internally they are using. And Spark is built on in memory processing. In memory processing, right? So in memory processing means before writing any output to hard disk. Here, when you say disk, this means hard disk. So after every processing, the intermediate output you're writing to hard disk. Here you're not writing your output, the processed output, to hard disk. you write your final copy to hard disk, but intermediate output, right? Those will store in a cache. Those will store in a cache. So when you process with in-memory processing across the globe, any platform, any processing area, in-memory is anytime faster than disk computation, anytime faster. But again, I have very valid point to work with this in-memory processing. First thing, if I have a good RAM available, because when you say in-memory, which means this is talking about what? This is talking about your RAM. This is the area where you RAM is a volatile memory, guys, right? RAM is a volatile memory. What do you understand by volatile? That when you're working, when you open a cell and you're working for some time, it can work. It can recall, it can recache, it can read from cache. But once you turned off your system, once you shut down your machine, all the data which you have worked on RAM, this is all gone. So your volatile memory is deleted when you shut down your machine, right? That's what is it is suggested, or a good practice. When you process something and you have achieved your expected output, make a file, store in a hard disk, because if it is in a RAM, it can be deleted anytime, right? So in memory processing means happening in a RAM. Disk computation means I have RAM available, but very less percentage of RAM is available, maybe 200 MB or 500 MB. So I cannot cache it more. Whenever I see cache computation, and I have a concept of uh, persistence and cache thing, which is available in Spark, it is very fast because they can read it from cache. And cache thing, if you're able to recall, it's kind of cookies concept only, that whatever information you have processed, they store somewhere in a form of cache. So Spark is a by default in memory processing, and MR is a disk computation. But if you do not have much RAM available, you have very less RAM available. Let's say, let's build a scenario. Say you have 100 GB data to process. Okay, your data size is 100 GB, and you have RAM available 4 GB. Your RAM is available 4 GB, and you're saying that I want to work with a Spark. Okay, because if I'm saying this MapReduce can take me a 1x time to process anything, if my cluster is prepared well, it has well built, so Spark can do the same job, their performance. Okay, so this 1x is a performance. 1x performance of MapReduce, Spark is 100x. They're 100 times faster than MapReduce, right? But they're 100 times faster if I create a cluster well, if my cluster is organized. If I'm creating just a number of cluster and I'm not organizing well my resources, CPU, RAM, and hard disk, I cannot achieve this 100x. To achieve this 100x, I have to be very good in the cluster computing, okay, especially to setting the cluster. So two different jobs are there. Administrator are very important, because admin people are the one who set all this RAM and configuration. And I can set my requirement of RAM for the job when I'm creating a job, right? So because when you write a job and when this job going and communicating to your environment, both are required, both things are important. So my case number one is what? In case number one, I'm saying I have 100 GB data. Okay, I have a 4 GB RAM and I want to work with a Spark. And we know that Spark is by default working with the in memory computation, right? But what is your size of in memory computation? What is the size of RAM? This is just 4 GB. So I I can maybe I may get output, but again, not expected expected as fast. Like it cannot give me output in fast way, because my resource is very less. My resource number 4 GB is very less. Maybe I can get error also if they're unable to cache that data, if this is filled already and there is no space. So it's like this is your container. If you're keep writing your cache, you're continuously writing your cache, at one point of time you'll see this is all full. So if this is all full with 4 GB and you again try to use for a cache, immediately this will throw you error. And what is that error? This is a memory out of bound exception. So while working with a Spark, one thing to say, tuning is very important. So job tuning, environment tuning, Okay, setting your cluster is very very important when you're working with the Spark. But when I say by default Spark is an in-memory computation, I can change it also. This is again in my wish now. It's in my control. I can I can change it from in-memory to disk or disk to in-memory. I can do that. So those things are allowed in Spark. But MR, I don't have such provision available. I have disk computation. I have very limited RAM concept available. So one quick thing from all this point, your takeaway is what? Spark can definitely deal with historical real time both. But if I have less RAM available, if I have such kind of situation where I have very limited RAM, let's say 4 GB or maybe 2 GB, even less than this, and my data volume is very high to process, what can help you better? MapReduce can help you better in such scenario. When you see such scenario, MR can be much better than a Spark. Okay, so always see the configuration. Always talk about resources. It's not that you know some mathematical data sets. You know the configuration. You're just crunching with them. We have to understand the objective, and based on the application flow, we'll have to go on. So this is a comparison between MR and Spark. Today, our agenda is to talk about MapReduce. So let's start the MapReduce part. First recap. So in Hadoop, when we started, we talked about three different generations, right? 1.x, 2.x, and 3.x. So three different generation we have seen, and currently third generation is under developing mode. 2.x, 2.9.0 we have worked on. Uh, 2.9 and 2.x I think 2.6.0 we have set up in our system. So this cluster is already done. Single node cluster and multi node cluster. Both cluster performance we have seen, and we know concept of Hadoop also, that HDFS feature, HDFS pros and cons, that all block size, data locality, replication factor, fault tolerance, right one state multiple, distributed concept, right? These are all point, and we have proved that point after implementing the single node and multi node also. But those was a storage area, a first component of MapReduce, which we call as HDFS. And here we have seen uh, what is master and what is slave. So we say this is name node is a master, data node is a slave, and secondary name node is again a master. And then we have some port number here to communicate. And this port number you'll have to remember, because if you want to check the health condition of your node, so 50070, 50075, 50090. How about MapReduce? So MapReduce is 2 now. Okay, MapReduce is having two different version. What we got in 1.x is known as MR1, and what we get in 2.x is known as MR2. So MR1 and MR2, do we have any difference? Name, there we have a difference, a slight difference we have, okay? I'll tell you that difference. So this is MR2, and MR2 is also known as, YAN. YAN stand, we have separate topic as YAN. YAN stand for Yet Another Resource Negotiator. This is standing for Yet Another Resource Negotiator. Okay. So MR1 and MR2, let me write both. I'm just telling you the historical part so that you remember. If you read any articles or if you're going through some of the concept, this was in MapReduce 1 and this was in MapReduce 2, which we are calling as YAN also. So in MR1, MapReduce version 1, the processing area, right? This is a processing part. This was a storage. This is a processing. In MR1, we had a service called job tracker. And this was a master. And we had a task tracker, so which is tracking a task and which is tracking a job. This was a slave, and we had some port number. Let's not go to port number because we are not using MapReduce version 1. It was in 1.x. We are using currently this version. 2.x. So service is same, their concept is exactly similar, only few different points we have added. So obviously when I say I have version 1, version 2, version 3, obviously they're not going to have the same plugin, same API, same features, same properties. We'll see some different plugins are introduced and some different patches are coming, their performance are getting increased, right? So such points are there. In MR2, the same job trigger is known as a resource manager. Here, it is known as a resource manager, and resource manager is a master. I'll tell you this port number later as we go forward. Uh, Second is, what is a slave here in MR2? In MR2, slave is known as a node manager. So I always recommend you guys also, whenever you see so many different points with a different version, start comparing them. So when you compare, you immediately understand, okay, this is what we call in MR2, this is what we call in MR1, this is what service we have in HDFS. So storage we understand. Let's see what is a MapReduce. What is a MapReduce? Is it a language, or is it a tool? Is it a API? What exactly it is? So MR is not a programming language or programming tool, if you think that way. MapReduce is a programming model. So MR is a, your observation guys should be very very simple, so that your other peers, right, can also understand this concept. Because if I just write a bookish definition here, you can read that in books also, but how do we create a picture in our image? So to create a picture, always write, understand this in a plain definition. So MR is a programming model. It's a programming model, and this programming model, look, I'm not writing a language. There's a big difference between if I say programming language and programming model, because programming language can be my Java, C, Python, Scala, Ruby, Groovy, etc. They're the language. They're built using some concept, some syntax. This can work with any language. Hence I'm calling it a programming model. Idea behind MapReduce. Idea behind MapReduce is to process is to process historical data. Historical, or this is also known as a batch data. Historical or batch data. Okay, this is a limitation you can if you want to make a point. So idea behind MR is to process historical batch data, and it supports it supports all major languages. It supports all major language. Let me write in a bracket. So it supports Python, py for Python. Java, we know this is a native language, so using Java only this has got built. Then after Java, we know C also. We know I've seen code in Ruby also, Ruby on Rails. This is a functional programming thing. Then I've seen code in Scala. In fact, I have written code in Scala for MapReduce, but I found very, very difficulties while writing this. I achieved somehow my output, but I struggled a lot here because this is not built. That's what I said here while making a point between this two MR and Spark. I said native language is having more compatibility. So MR is more compatible with Java compared to Scala. And similarly, Spark is more compatible with the Scala because that's their native language. So it supports all these major languages or platform, etc. Okay, so let me write till this point. This is one MapReduce. And obviously, since this is also built using concept of Hadoop, they're also working with the concept of master and slave. So we know here also we have master and slave. Next point to see in MapReduce. Okay. Uh, in MR, so I think that point already I have written. Which one is a master and which one is slave. This I'm not talking about, guys. This is just for your information. I'm focusing here. in 2.x. This is what we have built on single node cluster and multi-node cluster. So let me open a text pad. Let me open a keynote first. So we'll learn first one hierarchy. We'll see how our job submission can happen. So before going to processing part, first I'm creating a flow for data copy. Okay. So I have a client. I have a client. The client is known as a edge node also. So client can be known as edge node, and this guy will submit a job, and this guy will submit a data also, right? So client is having, let's say, client is having in total 1 GB data. I'm taking one rough number, 1 GB data to copy. Let's first copy. We know how copy thing work. Client goes to name node, then they get information of data node in a sorted order based on rack information. Then client start writing to data node. Then they start replicating with the help of data node. That's what all happen when we copy the data. Right? But how the processing will happen? So let's say this 1 GB data is already copied in my cluster. So I'll create first, this is my HDFS with a parallel to this. Understand this picture very well, because if you understand this whole picture, whole scenario, you understand the complete concept of MapReduce. Uh, at least you can intuitively, you can get a image intuition. You can understand how this whole communication, how they are communicating peer to peer. This is my HDFS. And we know HDFS is a collection of data node, right? So all the data will go in this central repository. Client has written this data here using put command, HDFS DFS minus put source and destination. So we know put and copy from local command to copy the data, and say this is my data set. This is my data, 1 GB data. I'm just giving one reference name, okay? And this 1 GB data is stored in which in 5 different nodes. So I've got a nodes here, and let me create it actually. So I have total 5 nodes. Okay, I have a 5 node cluster. So my slaves 5, master I have 3. So master, we know how many master are required. Slave, we decrease and increase. We do not decrease and increase the number of master. Master are stable; they're fixed. So these are my 5 nodes. And in slave, how many different services we run? If you're able to recall our multi-node cluster, so 2 services will be there. Can I get a quick reply? How many people say how many services will run this? This I'm saying, guys, these are my slave nodes. 5 nodes are slave. So how many services will run here? What are the services will run here? Here, so number is okay, but if you tell me that we run this service, so I'm getting just answer from one guy. Other please try to answer, because these things will be needing in daily basis. DN1 and NM1, node manager 1. Okay, let me change the size of this. Okay, this is okay. This is DN1 NM1. I'll take some extra time, guys, to create this image. This is DN2 NM2. This is DN3 NM3. dn4 nm4 dn5 nm5. Likewise, I'll rename them. Okay, so these are my data nodes. Now, a quick question here. Let's first calculate uh, how this data will spread across my data node. So I know this 1 GB data will go in this 5 machine, but how it is going and in which machine it is going. So a quick calculation says this 1 GB data, this is my size of data, right? This is size of data. So size of data 1 GB will give me 8 blocks. And if I say I'm working with the replication factor 3, because obviously this environment is my production environment, production cluster, and here my I'll get total 24 blocks. Okay, so 24 blocks are spreaded like this. Let me first write these are racks. So if I write a rack, also I understand the block should not repeat on same rack, because we know remote rack and off rack concept. This is my R2. This is also my R2, and this is my R1 and R1. Let's just say I have randomly created this. Okay, this is my R1. This is also my R1. Now, if first block is going to, so I create a block also. These are my blocks, and these are my different data blocks. These are my different data blocks. So this is A, and I'll have from A B C D E F G. Likewise, I'll keep increasing. Okay, as my block increases. So I have A, then I have B, then I have C, then I have D, then I have E, then I have F, then I have G, then I have H last. So how many blocks total? 4 plus 4, 8. Let's rename them. A, B, C, D, E, F, G, and H. Okay. Now, if I'm working with a replication factor 3, since this is my production cluster, right? So when I'm working with the replication 3, I'll get the same block two more time. Let's adjust them next to this. Let's adjust this all the value. So we see total number of 24 blocks. So these are my number of blocks. Okay. Now how this copy will happen? So based on rack I'm writing. Okay. First I'm writing to rack 1. Let's say A is in rack 1. Okay. Let me create a bit small size. Okay. Okay, I think it's decreasing the inside point. No worries. That's okay. Let's deal with this only. Okay. So first block goes here. Then the same this A and A will obviously not go to rack 1 because this becomes off rack. So I'll not covering the same part again, rack thing. You understand internally that how this file will get copied. A is for A it's off rack, and for these are remote racks. R2 R2. I write B here in R1. Okay, and they will spread across. Sorry, let's write to R2. So when I'm writing this to R2, now this will go to R1 and another R1, because this will spread across the cluster. And I'm not doing this. This is all done by my master. It checks how my cluster is set, and based on that cluster activity, they start doing it. Now I'll write another C to R2, and I'll write C to here, and I'll write one more C to here. Then I'll write D to here. I'm just trying to balance my data set. Okay, I'm just trying to balance my block so that all the all the data node have a equal or similar types of block, very similar. So this is R2 and R2 and D. So E will go to let's say R2. So E other copy will go here and here. Then F also goes to here. Let me take this to this R1, or maybe this R1, and then F2 other will have R2 and R2, R2 and R2. Then G I'll take in G I'll take in R1. This R1 is already having so many things, so let me keep this to R2 only. So G this will go here, this G will go here. Almost equal cluster I believe, and this H I'll keep here in R1 again, and two more H will go to R2 and R2. This is in R2, and this is in also R2. So this information will store in my metadata now. We know that how many blocks are copied in which metadata and how many data node are having how many blocks. This is how my file copy is done. And this 1 GB data, this 1 GB data is obviously coming from some format. So what is the input type? That is first question. What is the input type? Because if I just give you data, let's take one scenario. I'm giving you one task. I'm giving you a task and I'm asking you. So my task says, take 1 TB historical data, and write a transformation code for me, and write a transformation. So I'm giving some activity to you guys. Transform the data, okay? Transform or do some manipulation on the data. Write transformation logic on data, and create a new file. Where you have your new output, where you have your transformed output, right? If I give you such question, right, and then I'm expecting you, can you tell me approach? I'm not asking you to write a code, I'm asking you to write an approach. What will be an approach if you pick this? So just to getting this volume of data, you cannot tell me anything, right? You don't know anything about this. What type of data is this? If I just give you volume of data, you cannot write a single line of code. So you need to know what is the type of this data. You need to know what is the input type. This is this a text data? It's a audio, video, images, weblog, RDBMS data, satellite information, radio frequency, server data, socket data. You should know this input type before. Without knowing this input type, you can't write a single code. Okay, so input format is very important. First, immediate takeaway here, whenever you see any data, first question, what is the input format? Once I know input format, then I can write a code and I can get output format also. Then my job becomes easy. But I should know first this part. Once I know this input format, then I can create output format. But this thing should be clear, because if I encrypt my data in some format and I don't tell you that which format I'm using, such as MD5 or some encryption technique I'm using, you cannot read that. So if you're not able to understand the data, how can you write a code, right? So first thing, when I gave you this image, immediately ask me what is the type of this data. This 1 GB data is, I'm saying you, this is a text data. Let's say I'll keep your job easy. I'll say this is a text data. So when I say this is a text data, uh, this is a text data. So after doing this, then you'll write some logic. You'll build the logic, and where you're building this. So copying part is done. Now we are going to processing part, and to process we need to write a code. What will be your environment? Your environment is, understand this. This is very important. Okay, so first thing, you are working in your company, right? So you're working in a project of Hadoop. So you are working with a standalone environment. You're working with the standalone environment. And what is a standalone environment? Standalone environment means your local machine, your office system, your laptop, or maybe your desktop, where you don't have anything running, right? Because your admin team have created a server. Your team has created a server where they stored, configured everything related to Hadoop, all ecosystem. And now if you want to access from your laptop, right? This is the server. The server is in cloud location. Maybe in uh, this is in Scotland. Okay, so if you want to access the server from your laptop, which is available in Pune, so how can you communicate between this machine and that machine, right? So to do this activity, you already have seen putty. This is how you access your AWS also, using putty. The same thing, you install this putty in your local laptop, you open this putty, you give all the address of the server, uh, as in what's the host name, what's the password, and then you log in there to the server. Then you do all this activity. So you have two things now. Local machine, you don't have any Hadoop thing running. In server, whatever task you're writing here, you are copying to the server using what? So Putty is a software to log in. Putty is a software to log in. What if I want to copy a file or a job or a jar file from here to this machine? Question is simple. I have logged in from this machine to server using Putty. My second question is, how can I write a file from this machine to this machine? I have say sample.txt. Okay, sample.txt, and I have written there something. Hey, this is my text data. I have written that statement in this sample.txt, and this sample.txt is present in my local machine, in my standalone desktop, and I want to copy from my desktop to server. Which software we use? So yes, yeah, there are two software, guys. And look, why I'm telling all these best practices, because this is what we apply in daily basis in a company. So if you're having good practice, you having good understanding about this all. So it's like you understand whole concept, and you can directly work with it. Okay, so while going for interviews, this the doubt will not be there, because if I ask a question and and immediately within 5 minutes I understand that the person has worked in a real-time environment or not, asking such questions. Okay, so if you have good practice on this, you won't find such questions. Now sample.txt is there. So when I want to copy, I get one answer. I copy from this to this using two software. I can use WinSCP, Windows Simple Copy, File Transfer. This is one, and second can be a FileZilla. So I've used both of them. And for Mac people, there's a CyberDuck. So this is anyways dependent on the operating system, which operating system you're using. This is for OS of Windows. CyberDuck, this is for Mac. This is for Mac system. This two, one and two. This two is for Windows OS. So make a practice of this all, guys. Okay. So I'm going to do one task in this my machine. Okay. In my machine, in my office laptop, local machine, what I did, I've installed my IDE, integrated development environment, in local machine. So step to build a job. Step to build a job. First, I'll install. If you do not have install permission, you will have to reach to admin. Install IDE, integrated development environment, and I think this is available in all of your machine. Can you get a quick reply, guys? This IntelliJ is available or not? Because I think while starting our session, I asked you to install this IntelliJ to write the code. How about you, other people? I'm getting only one response. Do we have this IntelliJ available in machine? If not, please check it. Okay, this is required to write a job. So when we start writing code in a Scala, in any of the processing area, so we'll be needing this ID, integrated development environment. IntelliJ is available in my local machine. This is not in cluster. Okay, this is in local machine. Second thing, second immediate thing, I go and I start adding all the plugin. So if I'm writing code in Scala, I'll add plugin in Scala. If I'm writing code in Python, I'll add plugin in Python. Okay, I'll tell you this all. Practical part will come later. Let's understand first concept. So uh, after installing IntelliJ, I'll install all the plugin. After installing all the plugin, I'll create a project. So there is my flow. After doing this, there is my flow. Any question if you find here, please ask me uh, again and again the thing. If this is not clear, then we cannot create a job. So first understand how to create, and then we'll go and see this creation part. Flow is this. I first open IntelliJ. Okay, then second I created my project. Third, I'll create my package. Fourth, after package, I'll create my class, right? And in this class, uh, I'll write my logic, which is my business logic. Business logic was what I ask you to write a transformation code. Okay, this transformation can be anything. Maybe I'm saying you there's a salary, or there's a dollar currently, right? So dollar is uh, rupees is trailing uh, behind dollar. So dollar is currently 75, as I have said yesterday. I've seen yesterday 75.10 somewhere. This price was since today's stock market already started. So this price may vary, but what I'm saying, this is one price of one stock. Let's say 75.10, or this is a currency of INR today. Now I want to use a round function here. Okay, I don't want to use this. I don't want this dot and all decimal. I want to store this as a 75.00. So whenever I see dot, if it is more than five or more than five, I go to the floor as a next value. If it is dot less than dot five, I go to the below value. As in, I don't go to next value. I take the same value. So this transformation is clear. A quick transformation from the salary point of or stock point. So I use a round function to transform this. I receive input from a stock market in this format, and I want to use a round function, and uh, after decimal just 00, no other point. So this thing is I'm calling as a business logic. I'll write some code to achieve this. Okay, first understand the fundamentals. So after business logic, I will go and compile this. So I'll compile this using compiler. And once I've compiled this class, right? Compile means I'm checking my test cases, my code is working or not. Because when you write a code, many things to observe. First thing, what is the total size? Second thing, optimization. Third thing, all the cases are correct or not. When I say cases, whatever function I have written in this logic, is it satisfying all the cases? Because if it is not satisfying all the cases, then I need to check using unit testing. And functions should fit with the data set, right? Because if you test it here and then when you copy this to server and it start failing, then whose responsibility is this? This is a developer responsibility. So developer job is to check this logic is working for all the cases which you have received from business. Okay, so after compilation, what I'll do, I'll create a bytecode. Once this code is compiled, and this code is written in which language? It's in assembly language. The language which you use to write a code or logic is known as assembly language. So we convert that assembly language into binary language. Binary is nothing but a bytecode, and in a Scala and Java, this bytecode is nothing but a jar file, archival file. J stands for Java archival. So once I get this bytecode and jar file, then Look, so far from this point to this point, I'm doing all this activity in my local machine, in my standalone machine, which is there in my system office. Okay. Once I get this bytecode, then what I'll do, I'll connect using WinSCP. So in WinSCP, I will give hostname and password of the server. I'll connect it, and my jar file is created in this desktop. So I'll copy from this desktop to this server. I'll copy this jar file using WinSCP software to a server. And what is this server? This server is having all Hadoop system available, all Hadoop things running in place, right? This is what my requirement, first requirement, to copy the jar file. Then submit this jar file. So that submission part I will cover tomorrow. Submission part and other activities, how this thing will happen, will continue from here. So far we have copied the data. Now I'm writing a job in this client, and when I submit a command, when I submit a jar file or job, how this data is going to process. This that analogy we are going to cover tomorrow. Um, MapReduce is, again, I'm repeating, it's very important concept, not from the writing perspective, but from understanding. So when you open, I have recommended you to read the book from O'Reilly, fourth edition, right? The book is O'Reilly, fourth edition.